So in this video, I'm going to look at transformations of graphs. Now the graph here is the circle that you're seeing is centered at the origin of the coordinate system and has a radius of 5. And the equation for this circle you can see as equation 1 up here at the top. And it's x squared plus y squared equals 25. The domain of this relationship is x has to be from -5 to +5, and likewise for y. Nice thing about this circle is it's completely symmetric with respect to the center, which means that anything you say about x is you could just as well say about y and vice versa. Anyway, we're going to look at what happens in terms of if you manipulate the input x and change it to something else, or likewise with y, how does that affect the graph? What happens with the graph? There are several different sorts of transformations. We're going to look at shifts, which are transformations where the whole circle is not deformed in any way, but it's moved to the right or left or up or down. And we'll also look at some basic deformations of the circle where the shape is changed. It turns out that adding something in the sense of replacing x with, let's say, x plus 2 is going to shift the circle. And on the other hand, if you were to go ahead and change the input x to something like, let's say, 3x, then that's a different sort of transformation. What that does is it's going to keep the circle where it's at in a sense, but it's going to change the circle's shape because it's going to change the possible inputs. So with what we have currently, the circle is stuck between -5 for x and +5 for x, because if x were bigger than 5, let's say x were 6, then if you squared 6, you'd be looking at 36, so 36 plus y squared equals 25. Not possible, because y squared has to be at least 0, and typically positive. Okay, so if we go ahead and look at the equation 2 here, which has x replaced with in the parentheses with x plus 2, you see it shifts the whole thing to the left. I turned off the first circle so we can see how this happened, but the circles have the same shape. All circles have the same shape, of course, but it also has the same size. The original circle had a diameter of 10 from -5 to +5. This one likewise has a diameter of 10, though it's going from -7 up to 3 in this particular case. Geometrically speaking, we'd say that the two circles are congruent. They have the same shape and size. Now, this of course is not actually a function. This is a relation, but what we can say here about relations will transfer to our discussion of functions in the next topic. Now there is one sort of transformation that we won't be looking at in this video, but we can do it in the next video. That's what happens if you were to replace x with its opposite or y with its opposite. Now what that does actually is it exchanges the left and the right. If you were to replace x with -x, then everything that's to the right goes to the left and vice versa. And in the case of a circle, that doesn't show up because, well, the circle is perfectly symmetric. If I go ahead and reflect it about the y-axis, which is what we call it a reflection when you replace x with its opposite. And if you replace y with its opposite, you'd be looking at a reflection about the x-axis. Well, those reflections aren't going to show us anything here because of the symmetry of the circle. Another sort of transformation which goes beyond the scope of your typical college algebra class is a rotation, where you can rotate the entire graph, so we won't be looking at that specifically. Okay, so here I'm back to our graph from which was shifted sort of counterintuitively. You'd expect that it's going to be shifted to the right. Maybe if you replace x with x plus 2, you might think, well, it's going to go 2 units to the right. One way of thinking why it goes backwards of what you might expect, you can think of the fact that maybe it's think of the coordinate system as shifting and not the graph itself. So that's one possible perspective. There's other ways of looking at this, and I encourage you to think about it yourself and convince yourself that somehow this all makes sense, even though it may intuitively seem kind of backwards. Well, it follows from that if we were to go ahead and look at equation 3, where instead of having x minus 2 as the input, we have x plus 2. Well, in that case, it's going to shift it. I think I may have just said that exactly backwards, but if we have x minus 2, it actually shifts it 2 units to the right. And similar sorts of things happen with y. If you can shift up by changing the y to y minus 1, for example, which would shift it 1 unit up, and you can shift it down in the same sort of way. Now, on the other hand, if we were to go ahead and look at what we have in the equation 4, I guess it is here. If you were to replace x with twice that, 2 times x, then that has the effect of actually compressing the graph by a factor of 1/2. Again, it might be kind of backwards of what you're thinking. You replace x with twice x. Well, what that means is since x itself would range, not the right term to use because it's actually the domain of the function or relation, but since x typically, or in the original circle, is going to range from -5 up to +5, it follows that if you were going to replace x with twice x, well, then twice x, 2x, has to go from 5 to -5, which means x itself goes from -2.5 to +2.5. Now here, down in this little box here, you'll notice that the 2x, after it's been squared, actually shows up in the equation spot up here as 4x squared, because of course when you square 2x, you get 4x squared. So here we see that compression, and you can see that the overall ellipse, which is this compressed circle, the x values have half the distance that they had before. The circle goes from -5 to +5, 10 units. The ellipse on the x-axis only ranges from -2.5 to +2.5, only 5 units. You can think of an ellipse as being a transformed circle. We'll be seeing later on when we talk about conic sections in more detail that you can think of a conic section as being actually the more general thing and a circle being a special case of that. Both perspectives work out perfectly well. Now we can do a similar sort of change in terms of y. If we were to replace y with 3y, then that's going to have the effect of compressing in the y direction by a factor of 1/3. So we would end up with a circle that, as far as y is concerned, is 1/3 as tall and is 1/3 as deep. And here we see it. So the x coordinates, x is still going from -5 to +5, but the y values have been changed so that they're ranging from only 1/3 of 5 in either direction from. And of course you could actually do both of those things together. We could go ahead and compress in the x direction, compress in the y direction. If you do the same compression in both cases, you really just get a smaller circle. If the compression in X is different from the compression in Y, then we're going to be dealing with an ellipse that shows that. So here, if we go ahead and input this the cube, not the first time, the square of 2x plus the square of 3y, so it'll be half as the dimensions in the x-coordinate and a third of the dimensions in the y-coordinate. And there we have it, our ellipse. Okay, that's it for this particular video. I'll take up some of the other issues having to do with transformations in our